So, hello everyone. Now we are going to see next problem of Letcode challenge called two sum. Input is a binary search tree. The problem is pretty simple. Let's read the problem. Given the root of binary search tree and the target number k, return true if there exist two elements in the BST such that their sum is equal to the given target. Okay, like we have given this tree and we need to find the sum of the two elements which is equal to the sum of the target we have given, like k is equal to 9 over there. So let's understand this problem that target we have given is equal to 9. So we need to check that sum of the two elements, if there exists the sum of the two elements which is equal to the 9, then we need to return true, otherwise false. Okay, so how can we check? So first we move over there and check it over there, then 5 is new. Then we come up this level, which is called second level. So first level and this is called second level. Okay. Now we are coming to second level check. 3 plus 6 is equal to 9 is over there. Yes, it's equal to 9. Then we're going to return 3. So this problem says, okay. So now let's see the approach that we are going to use over there. So let's see the approach. How we are going to solve this problem. Okay. So approach over there we are going to use using set we are going to solve this problem. First let's make a set. Okay. First, let's create a set, and we are going to check that first using recursion we are solve the problem. Okay. So first step is create a set. Okay. So we create a set, and we check that the root value, the value is for root value. We can put the value. The root value minus target value is present in the set. Then we are going to return true. Let's again understand what I'm saying. Let's see. A 9 minus 5, which is called target value, minus root value, is in set. So 9 minus 5 is equal to 4. 4 value is set over there? No, right now it's not. We need to find 2 value over there. Now, again come to this one. 9 minus 3 is equal to 6. Present in the set. Yes, over there it's in the set. Now we are going to return true. That's a simple approach we are going to use over there. So its time complexity becomes O of n because of the recursion we are using over there, and also space complexity O of n, and the time complexity also O of n because we iterate n numbers of time to check that this value is present in the set or not. So let's see the code. Just first we create a set over there and we check the base condition that there's any value present, there's any tree present over there or not. If not, then return false directly. If k minus root value, the k minus root value in set, then return true. And then we are going to add set dot add root value in a set, and then return root value left over there. It is left and it is right. And then the last we are going to return root. This function that we are going to we make this function. So that's all about this problem. So it was pretty simple problem. So thank you guys. Hope you guys understood.